All right, we're back again. I'm going to look at problem 131 from section 4.3. And again, we're looking at finding absolute maximums and absolute minimums, or finding local minimums and local maximums. So the first thing we need to do is find the derivative of this function. So let's try to find critical numbers here. And this will just use the power rule for this entire polynomial. It is a fourth degree polynomial, but it's no match for the ease of the power rule. So I've got 12x cubed plus 24x squared minus 36x. That's the derivative using the power rule. And I guess we should look at the original function here before we differentiate, just so we can actually see what it looks like as a graph. And so here I typed in 3x to the fourth. Well, I should probably type it in correctly. 3x to the fourth plus, and let's see here, 8x cubed minus 18x squared. So we'll go ahead and do that. Plus 8x cubed, and then minus 18x squared. All right, we'll just use the standard window. So we'll graph this, and it looks like it might be a W. There's something dropping down below here, and maybe I'll change this to minus 20 to 20. So we'll go to the window here for the vertical scale, and we'll look at negative 20 to 20. Go ahead and graph that again. And wow, we're going to have to go even further. So it can't have an absolute maximum, because we look, once we get past, looks like an exposition of 2, this thing's just going up, up, and away. And when we go left of, let's say, 5, it's going up, up, and away. And so it's tending toward infinity as x goes to infinity, or as x goes to minus infinity. Looks like they're probably, just by looking at the graph, a local maximum at 0, 0. A local minimum right here at maybe minus 1, 6. I can't quite tell, but we'll look at that in more detail. And there's probably a local minimum down here. And you know what? I'm going to have to change that window. And let's just be extreme about this, and let's dive down to, how about minus 40, just to guarantee we get this. And no, I didn't get it there. All right, negative 100. Okay, so it's somewhere down here. Okay, so no absolute maximums. It's going to be local maximum, local minimum, and another local minimum here. And this local minimum will actually be the absolute minimum when it bottoms out. And now I really do want to look at that, just to look at it qualitatively. And we'll go to 1,000 here. Okay, so now it's so extreme that everything else looks pretty flat, but there definitely is a local minimum here and another local minimum there. So I'm going to go back to the zoom 6 so it's not so extreme. All right, so I've got a local maximum, a local minimum, an absolute minimum way down here, but I've just put us back at the standard window. All right, so that's what we're looking at. Over the entire real numbers, we're going to have a local max, a local min, and an absolute minimum somewhere maybe around negative 2, 2.5. I'm not quite sure. All right, so there's our derivative. And we looked at the graph. We know there's going to be a local maximum, a local minimum, and an absolute minimum. And so we do need to find out where this derivative either does not exist, and it exists on its entire domain, or where the derivative goes to 0. So we'll set that to 0 and do our best to start factoring. I see a 12 in all of these numbers, and I can definitely factor out an x. Okay, and so I'll go ahead and factor that remaining polynomial, which is going to be plus 3 minus 1. Oops, and my cursor got out of hand there. So the critical numbers will be at x equals 0, -3, and 1. Okay, and so now we'll look at y at -3, y at 0, and y at 1. And I'm going to just use my calculator for that one, with exception to 0. I mean, I can plug in 0 everywhere. 0, 0. And do I dare putting 1 in? I can probably do 1. That's going to be 3 plus 8 is 11. 11 minus 18 be minus 7. And I'll take no chances. I'm going to check -3 in the calculator. So I'll go ahead, pull up the calculator again, go to second table, and just for confidence, we'll go ahead and put -3 in here. We'll use the calculator. -135. We could put 0 if you wanted to. And we got 0 and 1. We said we got -7. We'll go ahead and verify that as well. So at -3, we're at -135. So notice the shape of the graph is doing something like this. And so if we wanted to, rough sketch this, this ordered pair down here is going to be -3, -135, and that will be an absolute minimum. Right here, it's not an absolute minimum because, well, -3 and -135 is lower, but this will be a relative minimum, or local minimum. I guess I'll put both vocabulary words depending on which one you want to use. And right here, that's 0, 0, and that is a local maximum. There isn't an absolute maximum because the graph tends to infinity to the right and tends to infinity to the left. And so there we have it, local minimum at 1, -7, local maximum at 0, 0, and an absolute minimum at -3, -135.